All right. Now, lastly here, we're just going to review again, real quick. We're back in this view, but we're going to talk about how to change our view in infinite ways and what perspective we'd be looking at while we're doing that. So instead of looking at the cube before changing and the object changing in different directions to us staying the same in view, we're now going to be talking about how do we change view, and I'll discuss as I'm in that view what view we're looking in and why at all different directions. Because again, if you're thinking of using perspective in a way where you can turn 360 degrees around and around, up and down, and side to side, just like your inside is, infinite sphere, then you need to understand, all the ways you can use different things. So I just wanted to explain that briefly. It will only take a few minutes, but I think it's important so that when you start feeling a little liberated by knowing some of the facts we're teaching in the diagrams and some of the drawovers, you can understand, okay, what if I want to get this view and are looking down here, like in a comic book, or if I want some drastic view here, or I want a really subtle view this way. Hopefully this would help you realize where would I start with that view and what would it be replicating. So let's do some of that. So again, to review quickly, we have, again, we're always at our own eye level, our own center of vision. We're always at our own SP, and the flattened SP now represents us here, is now represented there like we talked a lot before. So again, if I'm standing the correct distance away from this particular illusion right in front of it, that same station point down there on the flat wall as a flap coming down represents those same, that exact same distance and idea of me standing there with real projected angles. And of course, the cone of vision is my field of distortion, and that doesn't change. What we're going to do now is talk about a lot of different changes. So for instance, why is it that when I look into the world, I don't see distortion? If I look over here quickly, that's not distorted, that stuff in the corner or way over here or something like that real quick. Why is that the case in a single? Because in a single view on a two-dimensional surface, of course, in real life, each time we change our center of vision rapidly or our eye level, we're actually like this. So let's say I'm saying over to you by the camera, this stuff in front of me is not distorted, but you are actually. I just can't see over there. By the time I change my view to you, I've changed my center of vision and I've changed my eye level. So instantly, I'm refocusing on things that are always in the cone. So we can't escape our own cone of vision. It's always right in front of us. So no matter how fast we turn our heads to say, well, I can't see any distortion, I can't see any distortion. What are you talking about when there's distortion out of the cone? I don't get what you're talking about. The idea is we can't see it in front of our own eyes because by the time we change the view fast enough, we still repositioned, again, our own cone of vision rapidly as we change view. So that we can never escape it. So that's why that happens. The distortion happens because in a single point of view on a two-dimensional surface that we can back away from and view our own view, it's going to get distorted at one point. We just can't see it because this peripheral is about how much we can really focus on before we have to change our view. And by that time, again, we've changed our cone of vision, we've changed our station point in direction, and we've changed our eye level and center of vision. So because of that, we can't see the distortion. I just wanted to make that clear. Okay, so let's start out here in our traditional view where we were before. That's our station point, straight here, there, and represented down there. How else do I look around the world in this same view without changing my horizon line eye level? Let's just say I want to maybe step back, go forward real close, but in particular, get out of this view. How do I change it? Well, if I go ahead and look with my center of vision and my eye level and I change like this, just rotate like this, of course, I'm carrying this whole setup with me everywhere I go. So I can have an infinite view of the horizon all around me, just like when you're standing in front of or in the middle of a field, you're turning around the whole time. So obviously, that's easy to do. So that's pretty easy to understand. And of course, any new angle I strike, the fixed objects around me, if that's the case, let's say I'm in a fixed environment, they all change perspective too, like the cube was just doing in the last part. So you have to consider not only how our object's changing to our view angle, but how you've changed your view angle too in relation to the environment around you. Now you could do a blank slate and say, no, I'm just doing this out of my imagination, then I'll do it. But you have to have reference points or else all you have is this blank, which really doesn't mean much other than reinforcing the rules of what we have as what we own in the world. And remember, like we talked about, all that other stuff is part of the world. This is ours. So again, if I'm looking over here and then suddenly want to look over there, I'm still in one point. I'm still in traditional 1 and 2 point because the horizon hasn't changed like this. That's normal. I'm looking straight out into the world like this. That doesn't change. But everything else around me changes, going from 1 point, 2 point, maybe even 3 point, depending if an object is tipping. So keep remembering that when this moves with us, which it does, every time I move, this entire setup and the station point being here, represented by that, it all moves with us exactly because it's always exactly parallel and perpendicular, fixed right in our center. It never is not, okay? So again, pretty easy to see that. If I change this again in a rotation, anywhere I look, it's always going down me. So we'll discuss 3-point now. Actually, no. I wanted to discuss looking down straight in 1 point. I alluded it to in lecture 1 or 2, but I'm going to do it again. Let's say you say, I want to look out here now. Okay, I want to be in 1 point. There's a city coming out of the ground, let's say, or a lot of objects that grow out of the ground. I don't want to be in 1 point perspective looking out this way. I want to look straight down into the ground like Superman flying. Well, again, if my picture plane suddenly goes from here, traditional, looking straight down, what happens is all the tops of the building, if I'm situated correctly, are still going this way and this way to me. That's rather obvious if I situate myself. But now the verticals are the things that are diminishing to the 1 point vanishing point, because my view, if I'm in a true 1 point looking down in the ground, my vanishing point is the core of the earth. The 1 point vanishing point has to be the core of the earth if you're truly looking straight down like Superman at the earth. It must be. So going from here to here truly has to be your 1 point center. If I turn my head like this to those straight up buildings coming forward and do this or this just to the side, I suddenly turn it to 2 point. So again, traditional 1 point into the horizon, let's just say I'm looking at a whole bunch of things in 1 point this way. These things are still perpendicular and parallel to my situation, but I turn straight into the ground. I am now looking straight into the core of the earth with things coming up toward me, going to the diminishment of foreshortening. And the other planes are all going down in width and as height. But if I turn it like this or swing it like that, suddenly I have those same buildings that were coming up straight to me kind of in a 1 point situation, now have turned and are in 2 point. So you can easily do 1 and 2 point perspective of looking straight down into the earth, which can be a really effective thing. Happens in comic books a lot and stuff like that. But you still have to understand the entire setup and all the rules are completely carried with you the same way. They just are carried 90 degrees down from that view to here. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. 90 is straight down. 0 degrees would be us considering ourselves not at an angle, at a down angle, but we're looking straight in the horizon. 10, 20, 30, 40, 45, halfway, 50, 60, 70, 80, 90, straight down. And that explains a down angle, basically, if we're talking about in degrees, okay? We're concerned with 1 point and just being either here or at 90 straight down. Anything in between is 3 point. Also, another way to look at 1 point, if we go from here and then suddenly looking out here and we're going, okay, I want to carry that with me. Now I want to look straight up into the sky. Again, everything changes and becomes the same. All you're saying is that buildings that are coming way above you are still acting in 1 point, just like towering. If you were in the middle of the tallest buildings in New York, those towering buildings would be moving away to the 1 point vanishing point. The 1 point vanishing point now, that would be in the sky, of course, straight above you, and everything would be diminishing to it. But you'd still treat a lot of the other side planes of the buildings the same as you would in traditional 1 point. It's just that the objects are doing different things because now it's the verticals that are going straight toward the vanishing point if you were looking straight up. That would be the difference. So play with these ideas. Don't just sit here and listen to me and go, oh, well, okay, this guy says that. Okay, go ahead and play with the drawings. Formalize them and just do little careful drawings saying, I'm lying on my back at a picnic, falling asleep, and I'm looking straight up at these tall buildings that are right next to some trees because the buildings have true verticals. Go ahead and draw some of those scenarios, okay? Same thing. And then as you spun, if you were at that picnic and then you turned your position on the blanket looking straight in the sky, then 1 point would then turn to 2 point in that case because you're no longer straight and you'd have to tilt your head. So essentially you would imagine if you were to be looking straight up at the buildings, turn a little bit if you wanted to, but then cock your head this way or that way, it would suddenly turn into 2 point. It gets confusing, but if you work it out using these elements and carefully thinking about the rules, you can actually work out a pretty really involved view once your head kind of snaps around the confusing angles and it works. So 1 point looking straight out, looking straight down, or straight up follows the same rules. And same when you cock your head this way or this way, it will be 2 point, looking straight up, 2 point. 1 point, 2 point, 2 point. If I am looking at 1 point at my wall in my room right now, but I cock my head this way, only straight over, I suddenly am drawing it in 2 point. 1 point wall, 2 point corner wall. Okay, same thing. Looking straight down, 2 point, 1 point, 2 point. 1 point, 2 point, 2 point. Same thing, okay? I know it's weird and annoying, but the physical explanation of this is a hell of a lot easier than doing it on a page sometimes because we're really looking at it. Okay, so if we're kind of covering the complete spectrum, so remember if we're in some kind of huge hamster ball here, like a giant sphere, then we've already covered looking all around the horizon in traditional 1 and 2 point like this, okay? That's been done. We've also covered turning any angle in that sphere and then looking straight down or straight up. So that's been covered. And then even straight down, cocking our head like this, we're at an angle and at an angle. But because we're looking straight into the earth or straight into the sky and just sliding and sliding, we're not particularly going into 3 point yet. How do we know we're in 3 point? Well, let's rehearse that now. We're in 2 point. As we discussed, standard 2 point, 1 point, 2 point, 1 point, 2 point, 1 point. Any angle that is between 0 and 90, and 0 and 90 looking straight up is technically in 3 point perspective. Therefore, if I'm just 2 degrees down, technically there'd be a tiny diminishment to verticals like what we saw with the cube. But instead of the cube now, that was tipping forward before. Now we're changing our angle to the world. The world is not changing like before. We were taking an object from the world before, that was the cube, and tipping it. Now we're saying the world isn't changing, our view is. So if I'm traditionally in 1 point like this, and then I look down 10%, 10 degrees, 20 degrees, 30 degrees, 40 degrees, 45. 45 would be right between 90, halfway between these two angles would be a 45-degree down angle with my picture plane. 10 degrees, 20 degrees, 30 degrees, 40 degrees, 45, 50, 60, 70, 80. Straight down would be 90, no longer in 3 point. 0 is no longer in 3 point. 90 is no longer in 3 point. But 80, 70, 60, 50, 40, 45, all the way to 10 is still in 3 point. Go back to 0, you're in traditional 1, 2 point again. Same thing when you look up. We're not in 2 point perspective now, but 10 degrees up, 20, 30, 40, 45, all the way up to 80. We're way up there at 80 and we're in 3 point. But then when we go to 90, we're suddenly in 1 and 2 point again. So it's kind of weird, but think of yourself as existing in a giant sphere, and those simple angle changes allow you to understand how you draw things. I understand you to have no idea how to approach that yet, but with the methods we're going to cover in the diagrams, along with these very clear thoughts of being inside this kind of giant sphere, it becomes easy to actually figure out from, oh, this corner of my room or that part of the city, how do I put that into a different view than I'm seeing? I want to be underneath that stuff and looking up. Well, if you can kind of sketch out the stuff you want to draw, then imagine what it might look like at a different under angle. We'll be able to show you real easy how to draw out some of those three-point angles to actually figure out your real down angle and up angle, your real degrees to the world. That part's easy actually with the measuring. It only takes like less than a minute, very, very fast. The hard part is to keep the visualization going well, so you understand it. So remember, it's not just the angles that can be confusing. That part actually, if you step it out, goes pretty well. The important part is you realize that if I want to measure myself in 3 point with this setup, you can do it easily, saying I want to be 47 degrees down angle for some reason, like an exact camera. Easy to do in 3 point, but you have to be able to visualize what and why you're carrying into the picture compositionally. So again, composition is the most important thing. Not only do you have to figure out the view, you have to figure out how would I block out an interesting composition at 47 degree angle, down angle, looking into this picture. How close do I want the corner of the building or the person walking down the street or the corner of the scene, then looking into it? That all is a lot of working out compositional variables. So all we're talking about here in this last segment quickly is variables. These are all variables of view you could turn around in a real environment. And when we're talking about going into 1 point and 2 point straight down or straight up, those are all variable ideas you could bring to the table for composition, as well as every single one of these little rotations like this all have that complete variable of all the 3 point angles in between the 0 and the 90 and all of them going up. So it's a huge amount of, inside that sphere, it's a huge amount of selection you have to go through if you really want to do different angles. But again, once you understand the perspective and can kind of play around with thumbnails, kind of throwing these ideas out on thumbnails, within a few minutes you can actually get a really great view that's quite complex. And other people might just say, you know, how did you ever come up with that? How do you even know how to draw to that? Well, people figured it out 100 years ago. So again, to cap off the physical lecture, I guess, the main point is this stuff, most of it was proven and figured out 500 years ago, 350, some of the harder stuff. You know, the proofs kept coming as artists and the mathematicians figured out the angles and stuff. But what we're left with, luckily and happily, is a lot of the institutions across the world in the early 20th century kind of got all their stuff together, architects and stuff, and a lot of this stuff has been common proofs that have been kind of translated by a few people, and I was lucky enough to have one of those people as my instructor and a few other people around the country, obviously, and that kind of culminated into rediscovering and re-talking about these ideas, which are fully measured 3-point, which allow any camera angle you want, not just 1 and 2 points. So the good news is I'm excited about passing this stuff on in very simple form and all the way to complex measuring to everybody. So as many lectures as it takes, that's what I'm going to do. All right? So let's get to the diagrams now. We're pretty much done with the physical explanation lecture part. And we're going to go mostly some diagrams next and then some eventually drawovers and all that kind of thing. Okay? So we'll see you in the diagrams, I guess. All righty?